Hi all, and welcome to lesson 6 of the blockchain smart contract freeCodeCamp video. In this video, we're going to learn even more advanced Brownie tools, including deploying to a testnet, working with remappings and importing code from other repositories, deploying to local chains, and importantly, mocking contracts and working with mocking to test our smart contracts. We're going to work on making the architecture of our code more blockchain agnostic. So we can deploy on Rinkeby, we can deploy on Kovan, we can deploy on Mainnet Ethereum with almost no difference in the way that we actually do the deploy script. We're going to test across networks. We're going to learn about what forking a blockchain is. And then the last thing we're going to do in this lesson is we're going to work with Git and upload our code to GitHub so we can participate in the world of blockchain. And if you follow along successfully, I will see a tweet from you at some point. So looking forward to that as well. With that, let's jump in.
All right, let's move on to our next project. We're going to take the Fund Me contract that we made recently in Remix and actually import that one into Brownie. With this, we're going to go over a lot more of the advanced features that Brownie has to offer us. And we're going to get into some more sophisticated testing and deployment mechanisms for this. So I'm going to make a new directory, Brownie Fund Me. We're going to cd into Brownie Fund Me. And remember, if you hit tab, it'll autocomplete. And we're going to open this up in a folder. And again, if code period doesn't work, you can always go up to File, Open Folder, and do it like that. We're in our Brownie Fund Me project, and we're going to initialize a new project by running Brownie init. And we're going to create a new contract called fundme.sol. And this is going to be exactly what we had before for our Fund Me contract. So if you have Remix up, great, you can go ahead and grab it, or you can check the GitHub repository associated with this course and just copy paste the code. Now, typically, this is where in our last project, we just ran Brownie compile. But what happens if we run Brownie compile here? Brownie is going to give us this error. It's going to say, hey, this source wasn't found. So what's going on here? Well, Remix understands that @chainlinks/contracts is an NPM package that it can import from. However, Brownie isn't aware of NPM packages, and Brownie can't actually download directly from NPM. However, Brownie can download directly from GitHub. So we have to tell Brownie where it should be downloading these third-party packages from so that we can use them in our contracts here. And while I'm in here, I might as well change the global compiler version to 0.6.6. And we'll just change the compiler version to caret 0.6.6 so that our linter is happy. So we need to tell Brownie where to import these contracts from GitHub instead of from NPM. Luckily, there is a package out there specifically created for downloading Chainlink contracts. The way that we can tell Brownie where to get these from is in our Brownie config. So let's create our Brownie config. And in here, we're going to create a dependencies section. And this is where we tell Brownie the organization/repo name at version that we want to download from. So to get these Chainlink contracts, we can look up Chainlink Brownie contracts, and we can use this repository to get it. So instead of downloading from NPM, we're just going to download directly from this GitHub repo. So we need to tell Brownie the organization, which is going to be Smart Contract Kit, the repository name, which is going to be Chainlink Brownie contracts, and then the version. You don't always have to use the latest version here. And in fact, we can go to the past 9 versions by clicking on the version history. We're actually going to be using 1.1.1. And yes, it does look like the latest version went backwards, but as of a recent release, as a 1.2.0 version of this package, all the releases of Chainlink Brownie contracts is going to match exactly the @Chainlink contracts NPM tag. So that's why it looks like this is an earlier version. So we'll say 1.1.1. So great. So now Brownie knows to download this repository from GitHub. Once we do that, everything in this contract section will be available for our Solidity code to import and use. However, that's not the final story here. We also need to tell Brownie what this @Chainlink thing means, because we're downloading from Smart Contract Kit /Chainlink Brownie contracts. Brownie's going, okay, cool. Well, what's this @Chainlink thing? So we need to tell Brownie whenever we're using @Chainlink, we're actually referring to this import. So we need to tell the compiler this. So let's add a new section. We'll say compiler. When it compiles Sulk, we need to remap at Chainlink. We need to say whenever you see at Chainlink here, it means we're referring to this package. So compiler Sulk remappings at Chainlink is equal to this package up here. Now, let's go ahead and try to compile. Perfect. We see here that it compiles successfully. And if we look in our build folder, in the contract section, we now have this new folder called dependencies. And if we even expand this a little bit, we can see it says dependencies, smart contract kit, Chainlink Brownie contracts at 1.1.1. And this is what it downloaded from that GitHub repository. It downloaded aggregator v3 interface and smart math Chainlink because we're using both of those files in our Solidity code. All right, great. So let's write our first script to deploy this to a development ganache chain, to Brownie's built-in chain. Let's do this. So in scripts, let's go ahead. We'll create a new file. Let's go ahead and build a simple deploy script to work with Rinkeby, and then we'll actually learn how to deploy this to our own local ganache development chain. So let's build our deploy script. So in scripts, we'll do new file, deploy.py, and we'll start by doing def deploy fund me. And then we'll do pass for now. And then we'll do our entry point of def main, and then we'll call deploy fund me. In this file, of course, we're going to do from Brownie import fund me so we can actually use this. And let's go ahead and build this deploy fund me function. So first, we're going to need to get an account. And same as last time, we used a function called getAccount, which would know to switch back and forth between if we were on development or if we were with an actual testnet that we could pull from our config. We can actually, once again, copy that function and use that in our script here. So once again, we can use that getAccount function that we had before. What I like to do with this getAccount is add it into its own file called helpful scripts. So what I'll do is create a new file called helpful scripts.py. And in here, I'll add that getAccount function, right? So literally just pasted it from our last project. And just a quick recap on what this is doing is we're saying if the network is in development, we're going to use the accounts 0 syntax. Otherwise, we're going to pull from our config. And of course, we're going to have to from Brownie import network, config, and accounts. And then of course, in our Brownie config, we're going to have to add wallets and from key. So let's go to our config. We'll do wallets from key. And we'll add our private key environment variable setup, which of course means that we're going to have to set .env to .env, and we're going to have to create a new file, .env, and we'll paste the exact same values from our last .env. So it's going to be our private key and our project ID. Kind of just a lot of the basics of the setup here. But now that we've added this getAccount to its own script, how do we actually use that in our deploy script? Depending on the version of Python that you're in, you might actually have to create a new file first, named __init__.py. You might not, but just in case, let's make it here because it doesn't hurt. And with this, now Python knows that it can import from other scripts and other packages in this project. So now we can do from scripts.helpfulScripts import getAccount. So we're importing that getAccount function from our helpful scripts here. And we're going to make this getAccount function a little bit more robust a little bit later, but for now, it'll work perfectly for what we're looking to do. Now we can just run our typical deploy function. Do fund me. We'll do the fund me contract equals fundme.deploy. And of course, we'll do from account. Because again, since this deploy is going to make a state change to the blockchain, we always need to do a from account section here. Then we can even do a little print. We'll do a printf here. So we'll say contract deployed to fundme.address. This is how we'll get the address of our fundme. And great, we can even go ahead and try this out right now. Remember you'll need some testnet Rinkeby Ethereum in your MetaMask. Brownie runs scripts, deploy.py, -- network, Rinkeby. And perfect. Contract deployed. Here it is. We can even go to Rinkeby Ether, scan again. And we can see the contract right here. Now, this is great and all, but if we look at our contract, it's kind of this blank jarble of bytes here, right? Nobody can actually see this contract and easily interact with it. And we want to make our contracts easy to interact with. What we can do on Etherscan is verify and publish our smart contracts. To verify our smart contract, all we have to do is hit that verify button. We'll choose our Solidity compiler type, which we know is going to be 0.6.6. And we know we're working with the MIT license here. Now, to continue, we would then have to add in all of the rest of these pieces. We'd have to do optimization, which is going to be yes. We'd enter our Solidity contract code below, which importing fundme like this wouldn't actually work because Etherscan doesn't know what @chainlink/contracts is. So we would have to copy paste the code from these imports to the top of our contract here. Removing these imports and copy pasting the code associated with these files is known as flattening. And this is an important concept for verifying our smart contracts on platforms like Etherscan. However, Brownie has a really nice way to get around this actually. What you can do is go to their main site, etherscan.io. You can sign in and sign up and get an API key. I've already signed up, so I'm going to go ahead and sign in here. Log in. And what we can do is we can go to my profile and scroll down to API keys. And this is where we can create an API key for us to interact with and programmatically verify our smart contracts on Etherscan. I've already got one here, but all we need to do is hit add. We'll give it a name. I'll call it verify Brownie. Continue. And we've created this new API token that will allow us to verify our smart contracts. What we'll do to use this in Brownie is we'll copy this API key and we'll move back to our scripts here. We'll set this API key as an environment variable. So we'll do export. The name of this is Etherscan token, and we'll set it equal to that key that we just got. Now, to verify this, all we have to do then is once we deploy this contract, we'll tell Brownie whether or not we want to verify the contract. So after our dictionary here, we'll do comma, publish, source equals true. We're saying, yes, we would like to publish our source code. Now, if we rerun this script, let's see what happens. Again, remember, we'll do Brownie, run, scripts, deploy.py, -- network space Rinkeby. And it says fundme has been deployed to here. Now we're going to say waiting for API rinkeby.etherscan.io to process contract, and we're submitting our code for verification here. And it'll say verification pending, verification complete, pass verified. And it'll say where the contract has been deployed and what's been done with it. Now, if we go back to Etherscan, again, we're going to have to go back to Rinkeby Etherscan because we deployed this to Rinkeby. And we paste this in. We now have this little check mark associated with our contract. And if we click contract, we can see all of the code in here for our contract. We have contract fundme, payable, you need to get more ETH, everything that we defined in here. And if we scroll up, we can see that they did indeed flatten this contract, right? They pasted that aggregator v3 interface import, and they also pasted that library SafeMath Chainlink. Now that's verified, we can even read the contract, see the different public variables in here, such as the owner, get version, get price, and all the exact same buttons that we saw in Remix. This read contract section is for all these view functions, right? The ones that aren't going to be making a state change. Write contract is going to be for when we want to call something like fund or withdraw. And we could even go ahead and interact with this. So for example, we could connect to Web3, MetaMask, okay, and it would automatically get connected to our MetaMask here. Then we could call fund and withdraw just like we did in Remix. If you want to give it a shot, go for it. All right, we're back in our code editor after successfully verifying one of our smart contracts on Etherscan. Now, just a quick note, sometimes the verification process can be a little bit touchy. And for version of Solidity 0.8.4, there's currently a bug that makes verifying a little bit tricky, but it's being worked on, so don't be discouraged if it gets a little bit funky. So this is great that we've written a deploy script for deploying directly to Rinkeby. However, as you know, we're always going to want to be able to deploy to our own local blockchains or Brownie's built-in development chain so we can test a lot quicker. And so that we can write some tests. But we have a little bit of an issue here. The first issue being that our Fund Me contract currently has an address hard-coded to work with the Rinkeby chain. So in fact, the way it's written right now, it's going to be hard to work with any other chain other than Rinkeby. The second bit is that these price feed contracts don't exist on a local Ganache chain or a Ganache chain that Brownie spins up. There's two ways we can get around this. We can do what's called forking and work on a forked simulated chain, or we can deploy a mock or deploy a fake price feed contract on our Ganache local development chain. Deploying mocks is a common design pattern used across all software engineering industries. And what it applies doing is deploying a fake version of something and interacting with it as if it's real. So again, right now, if I run Brownie, run scripts, deploy.py, and I don't set this network flag, we're going to actually have a default spinning up a Ganache chain, and it's even going to try to verify it, which it's going to run into an issue because we can't verify on a Ganache chain. So we have a couple issues that we need to address here in order for us to get this to work on a Ganache chain. Similar to how in this get account function in our helpful scripts, we do a little bit checking. We say, hey, if we're on a development network, use this development accounts version. Otherwise, pull from our config. We can do that exact same mentality, but with working with these mocks. So the first thing that we need to do is we need to parameterize our Fund Me Solidity smart contract so that we don't have this hard coded in here anymore. So what we can do is right when we deploy this contract, we'll tell it what price feed address it should use, right when we call our deploy function here, instead of having it hard coded. And we can add this parameter to our constructor. We'll say address price feed as an input parameter, and whatever input parameter we use here is going to be our global price feed address. So instead of us creating these aggregator v3 interface contracts right in the functions here, we're just going to create a global one. So we'll say aggregator v3 interface public price feed, and right in our constructor, right when we create this, we'll set price feed equals aggregator v3 interface price feed. And now what we can do is we can just delete this part, because as you can see, this is doing the exact same thing as up here. This is doing aggregator v3 interface price feed equals aggregator v3 interface, and then the address here. And we're going to do the exact same thing, but in our constructor, meaning right when we deploy this contract. So we can delete this, and we can delete it here as well in our get price function. We can even verify this with Brownie compile. And great, looks like it's compiling perfectly. Now, our deploy function is going to need to look a little bit different. We're going to need to pass the price feed address to our Fund Me contract. To do this, all we'd have to do is paste that address before we have our from account variable here. So this is how you can actually pass variables to constructors. Anything inside this constructor function, you can pass through Brownie in our deploy script here. So great. So we could 100% always just pass this Rinkeby address here, but that's not really going to solve our problem, obviously, right? The problem right now is that we always have this Rinkeby address here. We need to say if we are on a persistent network like Rinkeby, use the associated address. Otherwise, deploy mocks. And I know we've been talking about mocks. We'll get into them in a second. But let's first set this one up here. So we can check what network that we're on, again, by importing from Brownie this network bit. And we can say if network.show active does not equal development, then we'll say price feed address equals this address here, and we'll just pass this price feed address. Now this still doesn't solve our issue because we're just always passing this the Rinkeby hard-coded piece here. So what we want to do is parameterize where we get these addresses from. So instead, what we can do is in our Brownie config, we can add different addresses for different networks. So right underneath our .env, we'll add a new section called networks, and we'll do one called Rinkeby, and we'll say the FUSD price feed address is going to be this price feed address. Now what we can do in our deploy script is we can say, if we're not on a development network, let's grab the address from our networks section. This way we can define different addresses for this price feed across different networks. So we could add a Coven section, we could add a mainnet section, any other networks that we want to work with. All we need to do is add these flags for those contracts. So back in our deploy now, we can say the price feed address is going to get pulled from the config instead. So we'll say config, and this means we're going to have to import config from Brownie. We'll say config of networks based off of the network.show active, and then we'll use the FUSD price feed flag here. Perfect. So this little if statement is going to say, hey, if we're not on a development network, pull the address right from the config. And this will make it so that we can deploy to really anywhere that we want to deploy to. But what if we are on a development chain? Well, what do we do then? We can say else, if we're not on a development chain, we're going to have to deploy a mock. So right now, on all these live networks that we're working with, there is a version of this price feed contract, this price feed address. On our development chain, obviously, there won't be one because it's going to start off as blank. So what we can do is we can deploy our own version of the price feed contract. This is known as mocking, and we can interact with it accordingly. In order for us to deploy a price feed contract ourselves, we're obviously going to need to have the Solidity code associated with it. So what we can do is in our contract section, we'll create a new folder called test. When you create a test folder in your contracts folder, this is typically where mock contracts are going to go. And we'll create a new file called mock v3 aggregator.sol. And this is where we'll add the code for us to deploy our own price feed. Now I'm going to show you another repository pretty soon called the Chainlink Mix that we're going to work with. For now, if you're looking for one of these mocks, I highly recommend just pulling it from this Chainlink Mix repository. So we can grab it by going to contracts, test, and grabbing mock v3 aggregator.sol. And we can just copy this whole code and paste it into our mock v3 aggregator.sol. This has all the same exact functions as a real price feed contract, such as decimals and latest answer, which are going to be two of the ones we use the most. We can also see its constructor here. These are the variables that it takes whenever this contract is deployed. It takes a decimals and an initial answer. Decimals is of course going to be how many decimals that this contract should have, and initial answer is going to be its starting value, like 2000 for example. Once we have this contract in our test section, we can of course run Brownie compile, and Brownie will go ahead and compile this mock v3 aggregator as well. Because remember, Brownie compiles any contract in this contracts folder. Let's go back to our deploy script now that we have this mock v3 aggregator in here. Now what we can do is we can do a little else here saying, okay, well, if we are on a development chain, let's do something. Let's deploy these mocks. So let's do a little print statement here, a little printf saying the active network is, we'll do network.show active. Do another print statement, printf saying deploying mocks, Oops, I need a little closing there. And this doesn't need to be printf. It can just be a regular print. And then now, the same way we import Fund Me, we can import mock v3 aggregator. We can just deploy this contract the same way we deploy all of our other contracts. So we'll do mock v3 aggregator. deploy. And as we just learned, we have to add the parameters the constructor takes, which is going to be decimals and initial answer. So maybe we'll set decimals to 18, and then maybe we want to set the initial answer to 2000. So 2, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, comma. And of course, since we're deploying, we got to do a from, and we'll use our account here. Then we'll do another print saying mocks deployed. And of course, we're going to need to get this mock v3 aggregator's address. So we'll do mock aggregator equals this, and we'll set price feed address to equal our mock aggregator dot address. And now we're development or live network agnostic. If we deploy this on a live network, we'll use the address from our config. Otherwise, we'll use a fake aggregator contract that we've deployed. Let's go ahead and even try this on a development network. So we can do Brownie, run scripts, deploy.py. We don't need a network flag here. We'll hit enter. It'll spin up the ganache. And we even will deploy a mock aggregator contract first, and then we'll do our Fund Me part. Of course, we are running into an issue because we're trying to verify a contract on a chain that doesn't exist. Etherscan doesn't know about our local ganache chain. So to fix this, instead of doing publish source equals true, we can have this publish source be, again, based on what chain that we're on. So we'll go back to our Brownie config, and for Rinkeby, we'll say verify will be true. But for development, we'll say verify will be false. And back in our deploy script, we now say publish source is going to be pulled from our config. So again, we'll do config, networks, network.showActive, and then we'll do .get verify. This .get verify will make our lives a little bit easier if we forget to add verify in here. You could still do like this, like verify, but you'll run into some index errors if you forget to actually put the verify. So sometimes I get lazy, and it's just a little bit nicer like this. Now, if we run this again, deploy.py, we'll spin up our local ganache, we'll deploy a mock price feed contract, and then we'll deploy our Fund Me contract, and it completes successfully. So this is awesome. We have a way to PD our Fund Me contract that uses a price feed contract to our own local development environment with a mock, aka a fake price feed contract. This is awesome. Now this is great, but our deploy script is starting to look a little big and a little clunky. So let's actually clean this up to make it look a lot nicer. The first thing that we want to do is we want to fix this big 2000 number. Just looking at it right away, I'm not exactly sure how many zeros it has. So to make this look a little bit nicer and more readable, we can once again call on our friend web3.py. From web3, import web3, and down here we'll do web3.toWay 2000, comma, ether. This two-way function will just add 18 decimals to this 2000. So now this is much more readable that the initial value for this is going to be 2000. The next bit is that we're always deploying this mock v3 aggregator here. And if we already have a mock deployed to whatever network that we're working on, we don't need two mocks here. So what we can do then is right before we deploy this mock is we can do a little if statement. We can say if the length of our mock v3 aggregator is less than or equal to 0, only then will we deploy this mock v3 aggregator. Remember, we can check the length of our v3 aggregator because this v3 aggregator is just going to be a list of all the different v3 aggregators that we've deployed. Now, instead of using mock aggregator.address, we can just use mock v3 aggregator -1.address. So we're just saying, okay, great, just use the most recently deployed mock v3 aggregator. And then of course, we no longer need to set this as a variable. And that looks a little bit cleaner and will make this a little bit more efficient. So this deploying mocks bit though is going to be something that we're actually going to do relatively frequently. Let's even move this print statement up here. So instead, what I like to do is put this whole mock deploying bit in its own function in our helpful scripts. So let's open back up our helpful scripts. we'll do a new function called def deploy mocks, and we'll just paste that code in here. Of course, this means that in our helpful scripts, we're going to have to import mock v3 aggregator. We'll also have to do from web3 import web3. And instead of account, we'll just use this get account function. Now, back in our deploy script, we can just delete this whole part, replace it with deploy mocks, and then import deploy mocks from our helpful scripts. Deploy mocks. And then we can also delete this import now. Let's remove some of these comments if you'd like. This is starting to look a lot more sophisticated. And this is great because now we have a way to deploy based off if we're on a live chain or a development chain. And then one more thing I like to do so that everything is parameterized, I like to set these as static variables in the top of our helpful scripts. So I'll set decimals equals 18, and then I'll set starting price equals 2000. And then I'll have mock v3 aggregator to deploy to decimals, web3.2way to starting price here. So let's say now that I wanted to deploy this to my own Ganache instance. Well, what we could do is we could open up our Ganache here. We'll do quick start, and we'll just quickly create our own Ganache blockchain. In our script, let's go ahead and just run this deploy script again. Let's see what happens. Instead of Brownie spinning up its own Ganache here, it says attached to local RPC client listening at, and then this address here. Brownie is smart enough to detect if you're running your own Ganache instance here and will automatically attach itself to it, knowing that that is going to be a development environment. If we go to our Ganache, we'll see we have two transactions, which are going to be contract creations. We're going to create the price feed contract and then also our Fund Me contract. So this is great. This is great for testing quickly and locally, but there is an issue with this. For development networks, again, Brownie doesn't keep track of those. So in our build folders, if we go to deployments, we only are saving stuff from the Rinkeby chain here. So we would need to tell Brownie, hey, there's another network that we want you to work with. And we want you to remember the deployments to that chain. So what we can do is we can add a new network to our Brownie networks list. Remember, in Brownie networks list, we have all these different pieces in here. These are the ones that Brownie's going to not remember, and these are going to be the ones that Brownie remembers. So let's say we want to deploy to a Ganache chain and we want Brownie to remember those deployments. Well, we can add a network here. And this is going to be how we add any blockchain that we want, any EVM blockchain, like Avalanche, like Polygon, etc. To add a new network to the Brownie networks is we'll run Brownie networks add. We'll choose development or Ethereum. We're going to choose Ethereum because we want this to be a persistent network. We'll do Ethereum. We'll give it a name. I'm going to call this Ganache local. We need to give it a host, aka an HTTP address, which we know is right here. And then I'm just going to make this lowercase. And then a chain ID, which for this we know is 1337. Hit enter. Now, if I do Brownie networks list, I see a new blockchain called Ganache local. And this is going to reach out to our Ganache UI or our Ganache command line, depending on what we're running. Now, just a note, we are going to be deploying to this Ganache UI or Ganache CLI a lot for the rest of this lesson, so please keep your Ganache instance running. Now, what I can do is I can run Brownie, run scripts, deploy.py, -- network, Ganache local. Let's see what happens. Of course, we run into our first issue. Ganache local isn't development. So it's going to go ahead and try to pull from our config file. We don't want this. We want to actually deploy a mock for our local Ganache if a mock hasn't been deployed. So what we can do is we can extend our definition of what a development environment is. In our helpful scripts, we can add a flag in here. We'll say local blockchain environments equals, and this will be a list. We'll say development, of course, will be one, but we can also say Ganache local will be another. And now we can import this local blockchain environment into our deploy. So from at the top, from scripts.helpful scripts, do a comma here, paste that and save. Mine gets reformatted, which is really nice. And instead, we'll say if network.showActive not in local blockchain environments, then go ahead and pull from the config. What this is saying is it's saying if whatever network that we're on, if it isn't development or Ganache local, then go ahead and use a config. If it is one of these two, we're going to go ahead and deploy a mock here. Now that we have that, let's try this again. Brownie run scripts, deploy.py -- network, Ganache local, and we run into a different issue. We're saying, hey, you don't actually have enough gas. Well, why is this? Let's look at our get account function. Aha! This one is also looking directly for this development chain. This one will say if network.showActive is in local blockchain environments, then return accounts 0. So we're saying if the network we're working on is development or our Ganache local, then just return accounts 0. So let's try this. Okay, we're getting closer. Now we're running to this key error, Ganache local. Well, we do know how to fix that as well. In our config, we'll add this new network. We'll say Ganache local, and we'll set verify to false. So let's try this one more time. Perfect. Now mocks have been deployed and our Fund Me has been deployed. And if we look in our build folder in deployments, we now have a new chain ID for 1337 for saving these deployments. And it looks like in our Ganache chain, we have these actually saved in here, which is great. Now, an important thing to note, if you were to close this or delete this Ganache chain, all of your contracts will be lost. So you won't be able to interact with them again. To account for this, you can always delete 1337 and delete the entries in 1337 from your map.json. Or if you're fine deleting the whole build folder, you could delete the whole build folder. So now that we've deployed this, let's actually write a script to interact with this. So let's create a new file. We'll call it fund and withdraw.py. And this will be the script we use to fund and withdraw. So let's create a function called fund. We can say fund me equals the most recently deployed fund me. We're going to have to do from Brownie import fund me. We're going to have to get an account since we are going to be making some state changes. And we can just have this equal to get account. And we can do from scripts.helpful scripts import get account. Let's get the entrance fee so we can figure out how much we want to fund. Since this is going to resemble that FUSD price feed, it actually only has 8 decimals. 2, 1, 2, 3 for 2000, and 1, 2, 3, 4, 5, 6, 7, 8. The reason we want to do it like this too is because in our get price function, we know that it only has 8 decimal places. So we're multiplying it by an additional 10 here. We want it to resemble that as well. So we'll do 8 decimals, starting price of 2000 with 8 decimals here. And for our mock V3 aggregator, we're just going to use those exact values and we're not going to do the Web3 converting. We're just going to make it exactly those hard-coded values. Now we're going to want to get the entrance fee. So I've gone ahead and actually added a function called get entrance fee to our contract to make our lives a little bit easier here. I'm going to recommend that you take a look at this and then type it in yourself, or you just copy paste it from the GitHub repository so that we can use this get entrance fee because it's just a whole bunch of math here. So back in our fund and withdraw, what we can do then is we can do entrance fee equals fundme.get entrance fee. Get entrance fee. And we can even print out this entrance fee just to see if we're doing it right. But first, we're going to want to run Brownie, run scripts, deploy, network Ganache local, because we changed our fundme.sol. All right, great. And now we can run Brownie, run scripts, fund and withdraw, network Ganache local. And whoops, I need a main function. So we'll do def main, fund in here. And let's rerun this. And great, we can see this is the entrance fee. We'll do a little print statement here, a printf saying the current entry fee is entrance fee. We'll do a little print saying funding, and then we'll call fundme.fund. And of course, we're going to have to do a from account. And we're also going to send a value of entrance fee. Any low-level transaction data that we want to send with our transactions and function calls, we'll add in this little bracket piece here. Let's hit up. Let's do Brownie run scripts, fund and withdraw again. And great, it looks like it's going through perfectly. Awesome. Let's also do a withdraw function for the owner to withdraw. We'll say fundme equals fundme -1. Do account equals get account. And then we'll just call fundme.withdraw from account. And then right after fund is called, we'll have withdraw be called in our main function here. Let's go ahead and try this. Brownie run scripts, fund and withdraw, network, Ganache local. This is our funding script, our funding transaction going through, and then our withdraw transaction going through. Perfect. So it looks like our approximate functionality here works great. And this is a script that we can run on a main network if we'd like. Now, again, it's still much better for us to run. So now we're going to move into actually writing those tests. And for these tests, we're going to want to quit our Ganache UI. Let's go ahead and write some of these tests. Create a new file called test fundme.py. We'll quickly speed through this test because we're not going to learn too much new here. Keep in mind, when we run this test, we're going to want it to be able to work independent of the network that we're working on. So let's just keep that in mind. Let's do a test just to see if we can fund and withdraw. So we'll do def test can fund and withdraw. And we'll do basically exactly what we've done before. Do account equals get account. And of course, we'll do from scripts, that helpful scripts, import get account. Then we'll want to deploy fundme, and we can even just use our deploy fundme script in our deploy.py. So we can do from scripts dot deploy import deploy fundme. In our deploy fundme at the bottom, we'll just say return fundme so that our test can now have this fundme contract for it to work with. So now we'll say fundme equals deploy fundme. We'll grab the entrance fee, which will be equal to fundme.get entrance fee. And then let's go ahead and fund it. So we'll do transaction equals fundme.fund. And we'll call from account. We'll do value entrance fee. We'll do tx.wait1. We'll do an assert here. We'll do assert fundme.address to amount funded. It's going to be account.address. It's going to be equal to the entrance fee. So we want to check that our address and the amount that we funded is being adequately recorded. And then we'll do transaction 2 will be fundme.withdraw from account. We'll do tx2.wait1. And then we'll assert fundme.address to amount funded account.address equals 0. And let's go ahead and run this test. So we'll do Brownie test. And perfect. Looks like it's doing well. Now you may be wondering why sometimes we use the -- network flag and sometimes we don't. In our network section, Brownie automatically picks a default network to use. And the default is always set to development. However, we could set this to be anything that we wanted. We could set the default to be Ganache local. We could set it to be Rinkeby, whatever we want here. Whatever you set for the default in your Brownie config is what the network will be defaulted to. So right now, when we run Brownie test, this is equivalent to running Brownie test -- network development. We can even go ahead and run that too. Now, we could also run this test on Rinkeby, and we will in a second, but oftentimes we don't want to test all of our functionality on Rinkeby and on live networks because it's going to take a long time for them to run. So sometimes we only want to run tests on our local chains. Well, how do we do that? We can use PyTest's skip functionality to do so. To work with PyTest, we're going to first need to install it. So go ahead and run pip install PyTest. To demonstrate this, let's create a test that makes sure only the owner can withdraw and nobody else can. So we'll call this def test only owner can withdraw. To skip this test, if we're not on a local network, we'll first check the network. We'll say if network.showActive is not in, and yep, probably would have guessed it, we're going to pull this local blockchain environments in from our helpful scripts. So we'll do comma, local blockchain environments. And we're going to say if the network.showActive is not in this list of local blockchain environments, we're going to do pytest.skip and say only for local testing. Now, of course, we're going to have to import network. And we're also going to have to import PyTest. Now, if I try to run this test here with Brownie test -k -network Rinkeby, it should skip. Perfect. And we do see this S here, meaning that it skipped this function. If we run this with --network development, it should go ahead and run this and it'll pass because nothing happens in this function. And it does. Perfect. Let's keep going. So now we'll say account equals get account. We'll say fund me equals deploy fund me. And now let's get a different account to try to call the withdraw function. So we'll say bad actor equal, and this will just give us a blank random account, but we do have to import accounts from Brownie here. Now we want to test to see that them calling this withdraw function actually reverts them and causes an exception. Because if I try to do fund me.withdraw from bad actor right now, what do you think will happen? Well, we know in our fundme.sol, our withdraw function has the only owner modifier. So technically, only the owner should be able to call this function. So what happens? Actually, we don't even need this get account bit. Let's just go ahead and delete that. So what happens if somebody else tries to call this withdraw function? Well, let's go ahead and test this. We'll do Brownie test -k test only owner can withdraw. And you can see we're getting this error here. We're getting brownie.exceptions.virtualmachineerror revert from this fundme.withdraw. Well, we want this to happen. We're expecting this to happen. So how do we test that we want this to happen? Well, we just need to tell our test that we want this to happen. So first, we're going to have to import from Brownie this exceptions package. This way we can tell our test exactly what exception we're expecting to see. Then we'll say with pytest.raises exceptions.virtualmachineerror fundme.withdraw, and then we'll just copy this line down here. Now, what this is telling our test is that if this reverts with this virtual machine error, that's good. We're saying we want you to revert when you try to call this line. So if we delete this line and hit up and try to run this again, we can see that it now passes. And this is exactly what we're expecting. So this is awesome. All right, we've learned a lot of fantastic tools for working with Brownie here. Now, the last version of testing that I want to show you how to use is Mainnet Forking. Mainnet Forking is incredibly powerful when we're working with smart contracts on mainnet that we want to test locally. So let's talk about forking for a minute. So on the left here, I have a blockchain, right? An example of a blockchain. This is going to be like a testnet, like Rinkeby, or something like Mainnet, right? This is going to be a blockchain that we actually deploy to. Now, there are a whole bunch of blocks in here, right? And there's a huge chain that we can actually work with. All of this information is public information, right? This block is going to have like transaction, transaction. It's going to have, each one of these blocks is going to have a whole bunch of transactions, and all this information is here. In addition to all these transactions, it's going to have price feed contracts, Aave contracts, etc. It's going to have all these different contracts in it. So hypothetically, if it's all already there, we should be able to basically copy this whole blockchain and do some simulations ourselves. And that's exactly what forking does. A forked blockchain literally takes a copy of an existing blockchain on the left here and brings it into our local computer for us to work with. We actually have control of this blockchain since it's going to run on our local computer, similar to Ganache. Now, all the interactions that we do on this local blockchain are not going to affect the real blockchain because it's our local chain, right? It's a simulated blockchain. But because it's simulated, we can go ahead and interact with price feeds. We can interact with Aave. We can interact with all these different contracts that are already going to be on chain. Mainnet Fork is a built-in part of Brownie and also pulls from Infura the same way it works with Rinkeby and Coven and everything else. We can start to interact with the Mainnet Fork contracts the exact same way, therefore. So we can take this whole Rinkeby section, copy it, paste it, and we'll just change this FUSD price feed address to its mainnet address. So we'll go to docs.chain.link, Ethereum price feeds. We'll get FUSD here, copy that, and we'll paste it into here, and we'll change this to mainnet fork. And since this is going to be a fork, of course, for verify, we're going to do false. Now, if we try to run one of our scripts, like Brownie runs scripts deploy.py --network mainnet fork, you'll see we'll actually run into an issue here. It's saying insufficient funds for transfer. In our deploy script, when we do our get account and our helpful scripts, right now we're using accounts.ag config wallets from key. Yes, it's going to be our account, which right now has 0 money in it on mainnet. So Brownie's right away going to say, hey, you don't have any money on mainnet. What's the deal? So we need to tell Brownie that when we're working with mainnet fork, it should create us a fake account with 100 ETH in it. However, we don't want it to deploy a mock because the price feed contracts already exist. So we don't want it to deploy a mock, but we do want it to get us an account here. So typically what I like to do is I'll add another variable here and I'll call it forked local environments. And I'll add mainnet fork in here. And I'll use this now as part of my if statements. So I'll say if network.showActive in local blockchain environments or network.showActive in forked local environments, then we're going to go ahead and return account 0. However, in our deploy.py, mainnet fork is not going to be in this local blockchain environment, so we will just get our price feed from our config. So now, if I run this mainnet fork again, now if we run this, you'll see we'll still get an error. We'll get list index out of range. So Brownie's built-in forking mechanism doesn't actually come with its own accounts here. However, it has these issues. So what normally I like to do is I like to create my own custom mainnet fork right in Brownie. The way we can create our own development custom network is by using the Brownie networks add key. So we can do Brownie networks add. We'll make this a development network instead of a persistent network. And we'll call this mainnet fork dev. To set this up, we'll do a Ganache CLI. So we'll say the command to run this fork is going to be Ganache CLI. The host is going to be the same as always, http://127.0.0.1. Fork is going to be equal to, and this is where we just put https mainnet.infura.io/v3/web3 infura project ID. Now don't hit enter quite yet. I'm going to explain a couple things. So this single quote means run this as is. If we ran this without the single quote, our environment variable would get actualized here, and we'd always have to use whatever our current environment variable is. So we want to have this little semicolon here. Then we would do accounts equal 10. This tells Brownie for us to set up 10 fake accounts for us. We'll give it a mnemonic of Brownie. So we'll say, great, make those accounts, just have a mnemonic of Brownie. And we'll do port equals 8545. Now, once again, don't hit enter quite yet. I do want to explain one other thing. So this is great for working with Infura and forking from Infura. However, I have to note that performance-wise, forking from Infura has pretty much always given me an issue. So I prefer actually to fork from this application called Alchemy. And in fact, if you'd like, you could set up all of your networks to work with Alchemy by modifying them. I'm going to go ahead and sign in here, and we're going to give it an Alchemy URL instead of an Infura URL. So I'm going to go ahead and create an app. I'm going to call this Fund Me Demo. Description will also be a Fund Me Demo. Be a development environment on the Ethereum mainnet. Let's create this. We can now view the details of this. We'll go to View Key, and we'll copy this HTTP address, and we'll move back over here. And for forking, we can just delete everything next to this fork, and we'll just paste that in here instead. And let's go ahead and hit enter. You'll know you've done this right if you can see something like this. Mainnet Fork Dev has been added. Oftentimes, in my example, I will actually just delete Mainnet Fork and have Mainnet Fork Dev be my default for Mainnet Fork. But for us, we're going to go ahead and do Mainnet Fork Dev. So in our config, we're going to change Mainnet Fork to Mainnet Fork Dev. And so since we're giving this a different name, that means in our helpful scripts, we're going to have to do a comma here and say Mainnet Fork Dev. All right, great. Now our get account should return account 0 for Mainnet Fork Dev, and it should actually work. So let's run our script again. Brownie runs scripts, deploy -- network mainnet fork dev, and perfect. We're running our mainnet fork dev, and it is running successfully. Now we should also be able to test exactly the same way. Let's look at our test real quick. Test Fund Me, and see, okay, cool. We're going to be skipping this one since mainnet fork dev isn't in the local blockchain networks, but this should work perfectly. And then oftentimes in my tests here, I'll actually do like a little plus 100 or something for entrance fee, just in case I need like a little bit more money for whatever reason. So but now if we run Brownie test -- network mainnet fork dev, we'll see that this does indeed pass, and this is awesome. So this is fantastic, incredibly powerful project here. Now we're going to teach you how to actually share your code and enter the world of open source and decentralized code. The way the world works when sharing code and sharing ideas and collaborating together is they use what's called open source Git repositories. GitHub is an example of one of these Git repositories that we can use to share our code. And it's one of the dominant ways that smart contract engineers share ideas and share code. We are now going to learn how to add our code to GitHub, and then we can even share the code and show the world what we've built and what we've done. This isn't going to be a full end-to-end Git course. However, there are some links in the course repository that will show you how to work with Git, work with GitHub, and work with version control. So the first thing that we're going to do is we're going to come to GitHub and we're going to sign up for a service. Add our email, create a password, enter your username. No. Now we'll go to our email to verify it. We'll continue. We're going to be working with some collaborative coding. We're going to choose the free edition, and perfect. We are now in GitHub. Now that we're in GitHub, we're going to create our own first open sourced repository. So we're either going to hit this plus button here or create repository. Let's choose a repository name for this. We'll give it the same name as our main folder. So we'll call this Brownie Fund Me. We'll give it a description, maybe smart contract, application, and we'll hit create repository. This is where we're going to upload our code to share with the world. Back in our VS Code now, we're going to send this folder to that repository. First thing we need to do is installing Git. There are a couple different ways to install Git depending on the version that you're on. We'll put this link in the description to our course to actually install Git. Once you have it installed, you should be able to run git -- version and see a Git version here. Now we're going to initialize our repository in here by doing git init. We're going to choose a branch name. We're going to call it main. We'll go ahead and add our username and email to our git config, user.name quotes, free code camp video, git config user.email, freecodecampvideo@gmail.com. Now we're going to do a couple things to push all of our code to GitHub here. However, remember, we do not want to push our .env pieces up here. So we can do a couple of things. We can go ahead and delete this, of course, but we can also add in our .gitignore file a .env. This will help us so that we don't accidentally push our .env file to GitHub. We can choose what files we want to push by doing git, add, and then a period. And if we do git status, it'll now show us all the different files that we have staged to push to GitHub. If we look in here, we see we have git attributes, gitignore, Brownie config, fund me, some contracts, some scripts, but we do not have that .env file. If you were to remove .env from .gitignore and you ran git add .again, and then we did git status, we now see the .env in here. We do not want this in here, so we can do git remove -- cached .env. We'll add .env back to our .gitignore file, and then we'll run git status again. And then we'll run git add period, and then git status. And great, we do not see that .env in here, so that's very good. Now we'll commit this by git commit -m first commit. And now we can add this folder to our GitHub. Back in our GitHub, there's a little line here which even tells us how to do it. We're going to copy this line right here, git remote add origin, https freeCodeCamp Brownie Fund Me. I'm going to copy that, paste it in here, hit enter, and now we can just do this second line, git push -u origin main. We'll do git push -u origin main. And we get an output like this, and if we go back, we'll now see all of our files and folders in here. Now, I've already added my email and password in here, but instead of this, you'll probably get GitHub asking you for authorization. You can just go ahead and put your GitHub username in and your password in there. If your username and password doesn't work, you can come into GitHub, go down to settings, scroll down to developer settings, personal access tokens, and generate new token. We'll call this Brownie, and we'll want to give it at least repo authorization here, and we'll hit generate token. And instead of using your password, you can go ahead and use this GitHub token. Amazing. And you now have your first GitHub repository. We could even come in here, add some topics like Solidity, Chainlink, Python, Brownie, etc., so that we know what our file is about. And this is incredibly exciting. Now, I'm going to even encourage you to pop onto Twitter and share your excitement. I just made my first at GitHub repository, thanks to at freeCodeCamp, at Solidity, Lang, at Brownie F, at Chainlink. If you want to tag me, you can also tag at Patrick Alpha C, and then pop your repo in there. Go ahead and hit tweet. The community absolutely loves hearing about all the fantastic things people are doing in this ecosystem. So be sure to reach out, have fun, and engage. I know we've gone over a lot here, but let's talk a little bit about some testing pieces here. Now, a big question you might have is, well, okay, so I learned a ton of stuff. We learned about Mainnet Forking. I can do stuff on Ganache. I can use Brownie's Ganache. I can use Brownie's Mainnet Fork. I can do a testnet. There's all these places to do stuff. Where do I need to run my tests? The default for every single one of your contracts is as follows. You always 100% need to have tests that pass on a local Brownie spun up Ganache instance. That should be priority number one to get all your tests to pass on this. This means that you will need to deploy mocks. After that, the other place you absolutely need to have tests or do some type of development is on a testnet. These are going to be what's known as your integration tests, and we'll talk more about those later. So those are the two places you always need to have tests, development and a testnet. I think testing on Mainnet Fork and your own local ganache are optional. Testing on Mainnet Fork can be done and probably should be done whenever all of your contracts and all of your interactions are going to be on-chain, on one chain without any external off-chain components. Testing on your own local ganache is really more meant for tinkering and kind of exploring and seeing things yourself. So that's going to be the setup here. So great, now let's move into our most challenging example. Once you pass and once you complete this example, you basically will have all the tools to be an incredibly powerful smart contract developer. Then after that, we're going to show you the Chainlink Mix package and how to do what's called a Brownie bake to automatically open up this package with all these scripts and all these contracts pre-built in. This is going to make our lives substantially easier and faster for deploying our smart contracts. However, let's go through the process of understanding all the pieces that are going to be inside of this Brownie mix. Are you ready? You should be. Let's get excited and jump in.
Great work. Amazing job. You're doing so well. Getting this far. I'm so excited for you. You're just getting better and better with each lesson. Now, after this, we're going to go to the lottery or the sweepstakes or the raffle smart contract, whatever you want to call it, where we learn how to deploy a decentralized lottery, a decentralized application completely. And it's going to be fantastic, and I hope to see you there. Remember to take a break. Remember to have fun. Remember to send a tweet, and we'll see you in the next one.